Questions 18 and 19. We have a 500 kilogram roller coaster starting from rest at point A, moves down the curved track as shown to the right. Assume the track is frictionless. So we want to find the speed of the car at the lowest point B. So the speed, all right, so we're starting at the top and it has all GPE, and we're ending at B with no GPE but all KE. So we can say, all right, initial energy has to equal final energy. So GPE initial has to equal KE, or MGH has to equal 1/2 mv squared. Divide by mass on both sides, and we're going to get velocity equals the square root of 2gh. When you solve for that, you should come up with 30 meters per second. All right, number 19, find the speed of the car when it reaches point C. So we're at C this time, the speed at C. So at C, it's regained some height, so it has GPE at point C, and it also has a speed, so it has kinetic energy at C. So what we could do is say, all right, let's pick a point, and we could either pick point A or B. I'm going to pick point A. I'm going to call that GPE at A, and I'm going to say the initial energy has to equal the final energy, right? So I'm going to say GPE at A equals GPE at C plus kinetic energy at C. So GPE at, is that an A? It should be an A. We have mg height A equals mg height C plus 1/2 mv, the velocity at C, squared. Well, we can see that we have mass in each of the components of the equation, so we could divide by mass on both sides and just eliminate the mass. Mass over mass is 1. We're left with GHA equals GHC equals 1/2 VC squared. All right, so what we could do is subtract GHC from both sides, and we're going to get GHA minus GHC equals 1/2 VC squared. We can multiply both sides by 2 and factor out the G, and we would get 2G times quantity HA minus HC equals VC squared. Take the square root of both sides, and we're going to get velocity at C equals the square root of 2G times HA minus HC. So velocity at C equals the square root of 2 times 10 times quantity height of A is 45 minus the height of C is 25. And when we solve for that, we get a velocity at point C of 20 meters per second. And it kind of makes sense because when we were at the ground, it was 30 meters per second. But then when we transform some of that kinetic energy into gravitational potential energy at point C, the velocity has to be a little bit slower.